All right, let's get right to it. Welcome to this explainer. Today, our mission is simple. We're going to completely demystify Bitcoin and lay down the foundational basics of Web3, straight to the point. Look, if you want to understand the future of digital finance, you absolutely have to start at ground zero. So, we're going to strip away all the complex jargon and look directly under the hood at the architecture that made this entire revolution possible.
Okay, let's dive into this. Before Web3 was even a thing, computer scientists struggled for decades with something called the double spend problem. Think about it like this. Digital files are literally just data, right? If I have an MP3 or a PDF, I can copy and paste it a million times. So if I have a digital dollar, what's stopping me from just copying it and spending it twice? Well, historically, the only solution was to use a trusted third party, like a bank or a centralized server, to keep a master ledger and verify every single transaction. But as we know, that creates a massive central point of failure.
That entire paradigm changed in late 2008. That's when the pseudonymous Satoshi Nakamoto published a brilliant white paper proposing a purely peer-to-peer version of electronic cash. Instead of relying on that clunky central client-server model, Satoshi utilized a flat peer-to-peer network. Honestly, it's pretty similar to how BitTorrent works for file sharing. It completely replaced the central mint with a decentralized, hyper-resilient network of computers around the world, all working together to maintain one public ledger. So to really grasp this, we need to look at the actual life cycle of a single transaction. When you send Bitcoin, you first broadcast your proposed transaction out to the network. Network nodes, which are basically just computers running the Bitcoin software, group these new transactions together into what's called a block. But here's where the absolute magic happens. How do we actually secure it? Well, the network applies a mathematical function to hash the block, which essentially turns all that data into a unique string of characters. This new block is then chained chronologically to the previous block. If anyone, anywhere, tries to alter a past transaction, it immediately changes the hash of that block, which instantly breaks the entire chain that follows, alerting the whole network to the fraud. No way around it.
Now here's the billion-dollar question. How does a network agree on what the truth is without a boss telling them what to do? This is achieved through something called proof of work. Let's bust that jargon right now. Proof of work is essentially just a dynamic group signature. To add a block, miners must expend real, verifiable computing power and electricity to solve a super complex cryptographic puzzle. The network is programmed to always trust and build upon the longest chain. Why? Because the longest chain mathematically proves it has the absolute largest pool of CPU power backing it up. Basically, it's just way too costly for a bad actor to try and outpace the honest majority.
And that brings us to a really important number, 10. The network is beautifully, meticulously calibrated so that on average, it takes the entire global network of miners about 10 minutes to solve the current cryptographic puzzle and create a new block. When a miner successfully solves it, they get a block reward of newly minted Bitcoins plus the transaction fees from that block. This 10-minute heartbeat is literally the rhythm of the Bitcoin network.
Now you might be thinking, wait a minute, if this ledger is completely public and anyone can see every transaction, how on earth is my money actually safe? Well, this is where public-private key cryptography steps in. Think of your public key kind of like an email address. Anyone can see it and anyone can send Bitcoin to it. But your private key, that's like the password to that email account. When you want to spend your Bitcoin, you use your private key to digitally sign the transaction. The network can then mathematically verify your signature using your public key without you ever having to reveal your private key. It completely prevents unauthorized spending, leaving you in total, absolute control of your digital wealth.
Let's move to and see how this builds across a timeline, because the growth is wild. In 2008, the white paper drops. In January 2009, Nakamoto mines the Genesis block, the very first block, and actually embeds a newspaper headline about bank bailouts right into the code. Then in 2010, we get the first notable real-world transaction, 10,000 Bitcoins traded for 2 Papa John's pizzas. That was worth about $41 at the time. Today, depending on the market, those are multi-million-dollar pizzas. Fast forward to the landscape of 2026, detailed in recent global reports, and we've shifted completely from internet forum experiments to massive global institutional integration.
In fact, according to the 2026 PwC Global Crypto Regulation Report, institutional involvement has officially crossed the point of reversibility. We are no longer talking about a fringe movement of early internet rebels and cypherpunks. Not at all. Traditional banks, global asset managers, and major payment providers are actively embedding digital assets directly into their core infrastructures and balance sheets. Crypto is straight up taking on monetary functions that were once the exclusive, untouchable domain of traditional banking.
However, there is a catch. While the technology itself is inherently borderless, the reality of its adoption is highly local. Take El Salvador, for example. Back in 2021, they rolled out a top-down mandate making Bitcoin legal tender, even offering massive incentives for citizens to use a state-backed digital wallet called Chivo. But research from the National Bureau of Economic Research showed that everyday usage actually decreased over time. Why? Largely because citizens had very real privacy concerns regarding a state-backed tracking app. Conversely, in lots of other markets around the world, adoption isn't being forced by top-down mandates at all. It's being pulled into place organically by market realities and that institutional integration we just talked about.
And as this market matures, so does the global rulebook. By 2026, we're seeing a massive coordinated shift from policy design to actual on-the-ground implementation across the US, the EU, India, and beyond. Regulators are really converging on core principles. For you, this means the regulatory friction and the muddy lack of clarity that used to hold Web3 back is rapidly dissipating. It's paving the way for serious scale.
But wait, this brings us to a massive, practical hurdle. If you're buying a cup of coffee, you definitely can't stand there waiting 10 minutes for a block to confirm, and you absolutely don't want to pay a hefty network fee just for a $3 purchase. This scaling dilemma is exactly what sparked the famous block size war of 2017. One side of the community wanted to change the core code to just make the blocks bigger, while others argued that doing so would make the network way too heavy and eventually centralized. Ultimately, the winning solution was to scale things off-chain. So, the crucial point is really understanding the difference between Layer 1 and Layer 2. The Bitcoin mainnet, that's Layer 1, acts as the ultimate, highly secure, highly decentralized settlement layer. It is intentionally slow and robust. But on top of it sits the Lightning Network, which is a Layer 2 overlay. The Lightning Network allows for incredibly fast, practically free microtransactions that don't need to be immediately recorded on that slow base layer.
Think of the Lightning Network like a giant digital abacus. Two users lock up a set amount of Bitcoin on the main chain in what's called a 2-of-2 multi-signature address. That just means both users hold a key and have to agree. That lockup is basically the frame of the abacus. Once that channel is open, the users can instantly slide the beads, which are their balances, back and forth off-chain thousands of times if they want. The main Bitcoin network doesn't need to know about every single time a tiny bead is moved. It only needs to know the final tally when those users finally decide to close the channel and settle up on the main chain.
And this brilliantly illustrates the sheer power of the network effect. You don't literally need to open a direct channel with every single person you ever want to buy from. The Lightning Network uses something called onion routing, basically wrapping data in layers of encryption to instantly find a path of connected open channels between you and the merchant. It just hops through intermediate nodes to deliver the payment in milliseconds. This elegantly solves the scaling problem, allowing for everyday commerce while still borrowing the absolute security of the Bitcoin base layer. Though it is worth noting it does introduce a slight tendency towards centralization among the larger routing nodes that hold the most liquidity.
So, from Satoshi's initial 2008 white paper to the globally regulated multi-layered financial infrastructure of 2026, Bitcoin has entirely redefined what money can actually be. You now have the foundational literacy of how transactions are secured, how consensus is reached without a central boss, and how the network scales for the real world. So, I leave you with this. Now that you truly understand the architecture of Web3, how will you navigate and leverage this borderless future of finance? Keep learning, keep exploring, and I'll catch you in the next explainer.